Hi, I'm Jean, and today I'm going to talk about how implementations get away from designs when it comes to APIs and what we can do about that. This talk is dedicated to all the software teams who tell me they try to be good about their API specs ahead of time, and all the teams who tell me that they don't really know what their system does until it hits prod. What this talk is about is how API first as a concept sounds like a great idea, but there are some issues. So you might have heard of this term called API first. Companies like Postman are at the forefront of getting adoption for this idea. And it's really a nice, simple idea. Instead of writing your code first and then documenting and writing tests for your APIs later, API first just means upfront, you design, you mock out, you write the test, and then everyone's on the same page about what your API does. It's beautiful. You can go on with your lives. And then you also have documentation at the end. So this sounds great. This sounds like the right way to do things, but it's not getting as much adoption as one might expect. And so this talk is about, what else we need to do to make this kind of thing a reality. So in reality, according to the Postman 2020 State of the API report, only less than 5% of companies said they were fully API first. So despite the appeal, despite how great this all sounds, a very small number of companies say they're fully API first. And you could say that the other companies are just getting there, they're getting their heads together around API first. But I've noticed enough about companies that would make me think that there's a fundamental tension between this API first notion of doing things and just everywhere that modern software is headed. So this talk is about how we can bridge that gap. So the first part of this talk is about why the gap between design and implementation is just getting bigger and bigger. The next part is where I propose, I think the thing is, instead of API first, we need this API in the loop. It's not just me making a new buzzword, I promise. There's actually like a whole new set of ideas that this involves. And then at my company, Akita, we've been working on solutions for automatically keeping up-to-date API models for your system so that API specs aren't just a design tool for people, but they're really also a way for machines to tell you this is what the heck's going on with the whole system. And so I'll talk about how I believe that is what's bridging the gap, or what will bridge the gap between design and implementation. And a little bit about me and why I'm talking to you about this. I was previously an assistant professor at Carnegie Mellon University. My background is in programming tools. So I was working on programming language design, static program analysis, dynamic program analysis, everything about analyzing programs, program traces, that kind of thing. I realized APIs needed a lot of tooling, and that API traces are quite similar to program traces. And so that's a bit of a spoiler for later. But I left CMU to start Akita a few years ago. And over the course of the last few years, I've learned a lot about both the technical and non-technical problems around APIs. And so this talk is very much based on those learnings. All right, so let's get to it, the gap. And so you might think that DesignFirst is more appealing than ever before, because what's happening is, all these companies are making APIs. They're making money off their APIs. They're very motivated to make those APIs easier to use because that is the bottom line. And when it comes to DesignFirst, web APIs are a great place to apply that idea because it's high leverage. You know exactly, this is the surface area that developers are going to use. And also at the same time, software systems are just getting more complicated. So one way to mitigate that is design first some components and, know what they're doing so that it's not just all chaos everywhere. It makes a lot of sense. But what's been happening is this even bigger force, which is there's been this transformation of the way software development has been happening that has made design first very, very hard. So what's happened is the rise of SaaS and APIs has made it easier than ever to quickly add functionality to your system. And implementations are now depending more and more on not just what each piece is doing, but how all of the components are fitting together. And so now testing happens in production, and intended behavior is based on observed behavior. So instead of people saying, okay, this is my 40-line recipe, I know exactly what it's doing, it's totally self-contained. Most programs are now calling out to other components that are calling out to other components. Nothing is really self-contained anymore. And people don't really exactly know what's supposed to happen in a lot of the cases. This has blown up the software development lifecycle. So traditionally you had planning, then analysis, then design, implementation, testing, then that's when you shrink wrap the software and then shipped it off. Design is less top-down and more organic than ever before. Testing has decreased in scope, and now everything, most of the action is happening in prod. So your monitoring tools are getting a lot of use, your observability tools are getting a lot of use, but a lot of software development is now, look, we're going to make some real good hypotheses about what happens once we lob things over to prod, but that's our source of truth. That's everything. That's where the action happens. And so so along with DesignFirst, a lot of software practices have gone out the window. So I like to do this slide because I think sometimes, security teams or API teams will be like, well, these developers, they're really at odds with me. And I'm like, no, it's not you, it's everything. So these are some examples of lessons I used to teach when I was a faculty member that have just gone out the window. So debug with a debugger, not printf. Yep. In these modern systems, most of debugging is with logs. Use type checkers and linters to help you catch preventable errors before production. These do not exist across APIs. Test your code on small examples before running the whole thing. We're testing in prod now. And so it's not a surprise that API first, like write your test up front, write your mocks, agree on everything, that's gone out the window too, because everything's happening in this very implementation operation oriented way. And so measure twice, cut once just isn't working for APIs. The rise of SaaS and APIs has made it easier than ever for implementations to drift away from designs. The complexity of software behavior makes it hard to even understand what's going on with your systems, let alone plan and document what's going on. And the fact that APIs are products means that they're evolving. And so API documentation is very often not up to date. And implementations just don't do what designs expect if there was ever a design at all. Sometimes, people say, well, can't we just get developers more on board with doing things up front, documenting, writing tests? And I hope I've convinced you this is not a developer education problem. The issue is development is happening so quickly in such an organically evolving way. It's really at odds with any kind of design first approach right now. I have a solution, and now I'll tell you what it is. So the problem is that modern software is this organically evolving rainforest. Service-oriented, API-oriented development has made it possible to add and remove functionality more easily than ever before. So teams are just, they're adding services, calling services, adding their own services, all without consulting any kind of central authority. And so this has made it super easy for companies to scale up. You just, you want more functionality, add a team. They'll do whatever they want. You don't even need an architect until you're quite big anymore. That architect isn't overseeing everything that's going on. Life is good, life is easy, it's great. And every service and API can just accommodate and adapt to whoever shows up. It's so nice. It's so easy. Things can move fast. Your company can grow really big and you can make a ton of money. And I'm all without having any kind of central planning. And so this is great in a lot of ways. But APIs often do need to be planned gardens. So developers need to know how to call an API. They need to know what behavior to expect. Product managers, documentation writers, and the rest of the team need to know what they're working with. They need to know how to tell developers what API to call. They need to know what kind of documentation scaffolding to put around it. And also, whenever an API changes, people need to know. So if you're using the API, you need to know. If you're part of the team maintaining the API, you need to tell people. And so what's happening is that, if you want to make changes in an organically evolving way, that's not happening. So I'm just going to bring up this breaking change impact analysis at Shopify to show just how different breaking change management is to this like rapid, organic way of modern software development. And so according to one of the blog posts at Shopify, breaking the API contract with the ecosystem only happens when there are no alternatives or it's uneconomical to do otherwise. And if you look in this post, it's things like changing error types, like any kind of small change. So it's basically like stuff that's facing the developer, like you don't change at all. And whenever there's a change, you do mark breaking, mark possibly breaking. There's this metadata propagation of the change. And then the developer relations team goes out and talks to developers to make sure everything is fine. So changing the API at Shopify is a big deal. And this is totally a different world than if you're like within, like on the inside of a service-oriented company, you're just moving really fast. And so what's happening is that planned gardens must coexist with these evolving rainforests. So you have external APIs, they need more planning, they need more careful updating. But if you apply this kind of regime to all APIs across your entire system, this takes away all of the benefits of this decentralized development that is, people have adopted in the modern way. And so if you're a company that has APIs and you're moving towards service-oriented architecture, they're going to be part of your system that do well as planned gardens. You need them to be planned gardens. You need to know everything that's going on, even if there's like, organic parts, you're trimming those very carefully. And then there's parts of your system that just, let it run wild. That's what the developers want. That's what they need. That's what's going to let you be the most productive and iterate. And so this question is, how? And my proposed solution is this notion of API in the loop. So what this means is you have this notion of what the API is at every point, and it's not just what you design. So API planning and design, that's necessary for external APIs. It's great for all kinds of other APIs as well, but it's crucial to be able to update your idea of what the API spec is going to be based on the actual implementation and how that implementation actually hits production. And so, what you like, developers will say, what you design is often different than what you implement because, implementation concerns come up, other questions come up, there's just details that weren't in the design. And so there's, it's good to have a notion of the implementation API, but then any developer who works in a very modern tech stack will tell you what I implemented is super different, so like anything I unit tested, integration tested, etc. Like that does not cover the space of behavior that I might encounter once it's in production. And so there really needs to be these multiple API specs. So the design spec, and then the implementation spec, and then the, rubber hits the road production spec. And then the question is, how do we keep this API spec up to date everywhere while maintaining sanity? And one note is that when you design again, you really want to feed in, this is what it actually was, because like when you iterate on that design, it should really take into account this is what happened when users used it. But now there's this question of, well, are we going to have small armies of developers and documenters just, going at all the behavior with a magnifying glass, or is there some other way? Spoiler, that some other way is what we're building at Akita. So our solution is, look, we should be automatically learning API models so that we can always give you an idea of what is going on in the system. So the problem is the API spec in design doesn't match the API spec in implementation, doesn't match what's running in production. Why this is a problem is, well, have a hard time even telling your developer community what is the API that's being given to them, and then changes and all kinds of other things are very difficult. And so our solution is to make it easy as possible to keep an up-to-date API model. So this started out as a vanilla spec. So what are my endpoints? What are my fields? And we've just started enhancing that because people would ask us things like, well, can you tell us data formats like this RFC of date time, this kind of phone number, object types? Can you tell us performance information? So we realized, that is all part of what people want to know about an API. So we started layering that on top. And so it now adds up to a transparent API model. And we help software teams keep that up to date as an API implementation evolves. So how it works is Akita passively monitors API traffic across the entire system to build an API graph. So these are the endpoints. These are how all the endpoints are talking to each other. This is how it's changing over time. And we do that very non-invasively. So the idea is that you can drop Akita in to test, staging, or production. Akita doesn't proxy. You don't have to change any lines of code. We work through what's called PCAP filters primarily, and also a few integrations. Then Akita automatically models your API traffic, so endpoints, data formats, other kinds of properties, in order to let you search through that and filter, navigate, explore that information to understand what's going on. And we also automatically help detect breaking changes when that happens. So in the interest of time, I'll just give a quick demo where I'll show you visibility across endpoints and services with Akita. I'll show you what it looks like to search across the API graph. We'll dig into a single service, and then I'll show you a diff. I don't have a ton of time, so this is going to be quick, but if you want a longer demo, just sign up on our website and I'm happy to do a call with you. But what this shows is here's all Akita services that you would get across your system. And so we built this off of an open source train ticket service. And the idea is you would be able to get this map just by dropping Akita into a Kubernetes host or eventually just a port. And so you drop Akita in, we start mapping out, this is how services are talking to each other. We'll give you an overview of all of your services. You can dig in a little more. And then I might want to know, well, what are all the services that actually touch emails? And that'll filter this down for me. And so I might notice, well, it looks like everything's talking to TS travel service. So let me click into there and see what's going on. I can look at who's calling travel service at what endpoints are calling what other services. And then I can look down here for more details. And just a quick note, you can always download the full YAML API specification of this whole thing. And then you can also make your own views on top of it. Like I care about, just the emails, and then you can export these as well. And I can also diff across another service. And so this is, a diff between two versions of travel service. This diff says, well, two upstream services, TS admin travel service and TS preserve service, are affected by the differences we saw between these APIs. And we can explore the differences in a similar way. So here we automatically detect that something was an email and now got changed to a string. And so something to point out is Akita automatically infers endpoint structure, including these these path parameters for the endpoint structures. It automatically infers data types, the kinds of changes that happen, and a few other things. And so with Akita, you should be able to drop us into a system, see what's going on, and then also see what changes. All right, so I only have so much time. So I'll just wrap up by saying when it comes to APIs, we need both the planned gardens and the organically evolving rainforests because, APIs are products. They do need some design, but the development is happening in this modern way, and we should allow that to happen too. So we need some way to help the two coexist. And taking care to characterize what's happening in the implementation and what's happening when that implementation, hits production is crucial for both understanding the systems today and understanding, this is the product. An API product is the software system. That's what users are using. And that's crucial for going back and improving the designs, in my opinion. And so what I believe is the missing piece is this automatic learning of what's going on with your actual system behavior. And so I think this is an important part of the future, whether it's the Akita flavor of it, some other flavor of it, or a combination of tools. But DesignFirst can only meet implementations if the designs can acknowledge the implementations. And so I think that this is going to be a really exciting part of tooling to come in the next few years. And so you can find me on Twitter, you can find Akita on Twitter, and you can sign up for our beta, sign up for a demo. And I'm always happy just to hear feedback or thoughts or questions about, what is it that we do and how do we do it? Because I think that we can't solve this problem alone. And I think it's a really important problem to be solved. So look forward to hearing from you.